Hello po sa ating lahat. Good day po. Andito po ang aming group 3. Ipe-present po namin ang aming topic which is Basic Subsurface Flow, Steady State Condition. Ito po ang aming mga scope ng aming topics. Law of Darcy, Groundwater Confined Aquifer, Groundwater Unconfined Aquifer, Radial Groundwater in Confined Aquifer, Radial water in unconfined aquifer, travel time of groundwater in confined aquifer. Base po sa mga narinig ninyong mga topics, ang aming grupo po ay pinaghati-hatian ang mga topics pong ito para po mas mai-deliver namin sa inyo ng mas maayos at mas naiintindihan. Ang topic ko po ay Law of Darcy. What is Law of Darcy? Darcy law states the principle which govern the movement of fluid in the given substance. Darcy law equation that describe the capability of liquid to flow via any porous media like a rock. The law is based on the fact according to which the flow between 2 points is directly proportional to the pressure difference between the points, the distance, and the connectivity of flow within rocks between the points. Measuring the interconnectivity is known as permeability. Okay? Yung Darcy law daw po, siya po yung nag-i-influence ng movement ng liquid sa ating given substance. Doon naman po sa Darcy law equation, dinedescribe niya yung capability ng liquid na nagfo-flow via any porous media. Porous materials like rocks, which is naka-indicate naman po sa ating screen, sa ating nakuhang information. Okay, dito naman po tayo sa application ni Darcy law. Application of law of Darcy. One application of Darcy law is to flow water through an aquifer. Yung aquifer po, itatapik po ng ating mga other reporters. Kung ano po ba yung aquifer. Okay, Darcy law with the conversion of mass equation is equivalent to the groundwater flow equation, being one of the basic relationship of hydrogeology. Darcy law is also applied to describe oil, gas, and water flow through petroleum reservoirs. Guys, itong application of law, yung mga application natin, mas maiintindihan po natin to kapag meron tayong mga problem solving. Nga pala, bago natin simulan yung mga problem solving natin, ihanda natin ang ating mga calculators, ballpen, and syempre, kailangan natin ng scratch paper or ng papel. Okay? Dito tayo sa Darcy law equation. Bakit pa natin kailangan to? Okay, ito. To understand the mathematical aspect behind liquid flow in the substance, Darcy law can be described as relationship among the instantaneous rate of discharge through porous medium and pressure drop at a distance. Okay? Using the specific sign conversion, Darcy law is expressed as Q is equal to Ka times dH over dL, wherein Q is the rate of water flow, K is the hydraulic conductivity, A is the column cross-section area, dH over dL indicates the hydraulic gradient. Okay? Dito po na tayo magpo-proceed sa problem solving. Dito na po natin magagamit ang ating calculator and ballpen and some scratch paper. Okay. Problem solving. A confined water has a source of recharge. K for the aquifer is 50 m per day and N is equal to 0.2. The piezometric head in two wells 1,000 meter apart is 55 m and 50 m respectively from a common datum. Compute the following. cross-sectional area, hydraulic gradient, rate of flow for K is 50 m per day, Darcy velocity. Okay? Meron po tayong nakikitang figure sa ating screen. Yung mga given po natin, naka-indicate na po kung saan po sila lugar sa ating figure. Okay, dito po tayo sa ating solution. Ang una natin kukunin is yung unang hinihingi, which is yung cross-sectional area, which is 30 times 5 times 1,000. Saan ba natin nakuha yung mga numbers na to? Gawa-gawa na lang ba natin to? Hindi. Andito yung mga numbers na to sa ating problem. Yung 30, nakikita natin siya sa figure na yung average thickness ng aquifer. Yung 5 naman is yung 55 minus 50 is equal to 5. And yung 1,000 is yung distance from point to point ng dalawang well. Okay, 30 times 5 times 1,000 is equal to 150,000 m square. Okay? Hydraulic gradient. Hydraulic gradient is equal to 5 divided by 1,000. Saan ba natin ulit nakuha yung 5? Doon nga sa sinabi ko, yung 55 minus 5, 50 is equal to 5. So, magiging sagot po natin is 5 times 10 raised to negative 3 or 0.005 pala. 0.005. Pwede nyo naman gamitin yon yung kung mas okay sa inyo yung decimal. Pero sa akin, ang gagamitin ko is yung 5 times 10 raised to negative 3. Okay? Rate of flow for K is equal to 50 m per day. 50 m per day. Okay? Q is equal to K times A times DH over DL. Nakuha na ba natin yung mga given na yon? Yes, nakuha na natin. Which is yung K given, yung A kinuha natin, which is yung cross-sectional area. DH, DA, yun yung hydraulic gradient. Okay? Ipagta-times lang natin yung mga yon, di ba? Super basic. 50 times 150,000 times 0.05 times negative 3, which is 37,500 m cubic over day, per day. So, nakuha na natin yung rate of flow. Ano yung huli nating kukunin? Yung Darcy velocity, which is V is equal to Q over A. Hindi ko na-explain kung saan nakuha yung formula na yon kasi matagal na natin itong ginagamit. Yung Q is equal to V times A. Okay? V is equal to Q over A, which is Q is equal to yung 37,500 over A yung 150,000. So, magiging sagot natin dito is 37,500 over 150. Okay. Sagot dito ay 1/4 or 0.25. 25 m per day. Okay. Yun lang po yung part ko. Kung meron pa po, kung may mga tanong po kayo, pwede nyo naman po kaming i-chat. Or pwede nyo pong itanong si sir. Thank you po.
So, next is groundwater flow in confined and unconfined aquifer. Ang sabi dito, if there is a homogeneous porous formation extending from the ground surface up to an impervious bed underneath, rainwater percolating down in the soil saturates the formation and builds up the groundwater table or GWT. This aquifer under water table conditions is called an unconfined aquifer or water table aquifer, and well drilled into this aquifer is called a water table well. Mamaya papakita ko sa inyo yung figure para mas malaman natin yung difference ng confined saka unconfined, saka yung location ng wells. But first, alamin muna natin yung definition ng confined aquifer. Confined aquifers are permeable rock units that are usually deeper under the ground than unconfined aquifers. They are overlain by relatively impermeable rock or clay that limits groundwater movement into or out of the confined aquifer. Groundwater in a confined aquifer is under pressure and will rise up inside a borehole drilled into the aquifer. The level to which the water rises is called the potentiometric surface. An artesian flow is where the water flows out of the borehole under natural pressure. Confined aquifers may be replenished or recharged by rain or stream water, infiltrating the rock at some considerable distance away from the confined aquifer. Groundwater in these aquifers can sometimes be thousands of years old. And next is unconfined aquifer, where groundwater is in direct contact with the atmosphere through the open pore spaces of the overlying soil or rock. Then the aquifer is said to be unconfined. The upper groundwater surface is an unconfined aquifer is called the water table. The depth of the water table varies according to the factors such as topography, geology, season, and tidal effects, and the quantities of water being pumped from the aquifer. Unconfined aquifers are usually by rain or stream water infiltrating directly to the overlying soil. Typical examples of unconfined aquifer includes many areas of coastal lands and alluvial deposits in river valleys. Tapos, ayan yung figure ng type of aquifer saka yung location ng well. Kung makikita nyo yung precipitation, diyan pumapasok yung tubig directly dun sa confined aquifer, kung saan yung mas pinakamalalim na part. And sa taas niya is yung water table aquifer or yung confined aquifer, kung saan mas direct contact yung atmosphere. Tapos, next is yung problem solving na i-discuss naman ng ibang reporters. Thank you.
Since water is under pressure in an artesian aquifer, the storage coefficient of an artesian aquifer is attributed to the compressibility of the aquifer skeleton and expansibility of the pore water and is given by the relation. Storage coefficient is equal to specific weight of water multiplied to porosity of soil in decimal multiplied to the thickness of the confined aquifer times 1 divided by bulk modulus of elasticity of water plus 1 divided by porosity of soil multiplied by modulus of compressibility of the soil grains of the aquifer. Since water is practically incompressible, expansibility of the water as it comes out of the pore has a very little contribution to the value of the storage coefficient. The storage coefficient of an artesian aquifer ranges from 0.0005 to 0.005, while for a water table aquifer storage coefficient is equal to 0.05 to 0.3. The specific yield and storage coefficient values have to be determined for the aquifers in order to make estimates of the changes in the groundwater storage due to fluctuation in the piezometric surface from the relation. Change in groundwater storage is equal to involved area of aquifer multiplied by fluctuation in GWT or piezometric surface multiplied by storage coefficient or storage yield.
So let's proceed for the sample problems of confined and unconfined aquifers. First example is, in a certain alluvial basin of 100 square kilometer, 90 cubic millimeter of groundwater was pumped in a year and the groundwater table dropped by about 5 meters during the year. Assuming no replenishment, estimate the specific yield of the aquifer. If the specific retention is 12%, what is the porosity of soil? So for that, let's kukunin muna natin yung specific yield of the aquifer. So for the specific yield of the aquifer, change in groundwater storage is equals to area of aquifer times the fluctuation of the groundwater table times the specific yield of the aquifer. So for that, 90 times 10 raised to 6 excuse me, is equals to 100 times 10 raised to 6 times 5 times specific yield of the aquifer. So for that, calculation of that is specific yield of the aquifer is 0.18. And in porosity, we will use the 0.18 to get the porosity, which is N is equals to SY plus SR. So for that is 0.18 plus 0.12 is equals to 0.30 or 30%. So for the second example, an artisan aquifer 30-meter thick has a porosity of 25% and bulk modulus of compression 2000 kg per square centimeter. Estimate the storage coefficient of the aquifer. What fraction of this is attributable to the expansibility of water? So, for that, bulk modulus of elasticity of water is equals to 2.4 times 10 raised to 4 kg per square centimeter. So, for the solution, S is equals to specific weight of water, which is gamma sub W, for times porosity times thickness thickness of the confined aquifer times quantity of 1 sub K W plus 1 all over N K sub S. So for that, 1000 times 0.25 times 30 times the quantity of 1 all over 2.14 times 10 raised to 8 excuse me, plus 1 all over 0.25 times 2 times 10 raised to 7. So, another, for the simplification of it is 7,500 times the quantity of 0.467 times 10 raised to negative 8 plus 20 times 10 raised to negative 8. So, for the calculation of that is 1.54 times 10 raised to 3. So for the storage coefficient due to the expansibility of water as a percentage of S above. So for that is 7,500 times 0.467 times 10 raised to negative 8 divided by 7,500 times 20.467 times 10 raised to negative 8. And then times pa siya sa 100 para maging percentage siya. So matotal, ang result niya is 2.28%, which is negligible. So note, in less compressible formations like limestones for which E sub S is equals to 2 times 10 raised to 5 kilogram per square centimeter, S is equals to 5 times 10 raised to negative 5. And the fraction of this attributable to water and aquifer skeleton are 70% and 30% respectively.
Radial flow to a well. Groundwater resources in a confined aquifer with a non-steady state flow can be evaluated for the consideration of the construction of wells. A confined aquifer is a primary source for well tapping and is defined to be an aquifer bounded by an upper and lower bed of materials that allows only small amount of groundwater to penetrate through. A non-steady state flow is a flow in which the velocity changes direction or magnitude at some point in time. Equation 2 is the diffusion equation. The solution H quantity XYZT gives the value of the hydraulic head at any point in a flow field at any time. In this form, the equation describes a flow through a saturated anisotropic porous medium. Incorporating the two basic assumptions of essentially horizontal flow obeying Darcy laws, which reduces the equation to a two-dimensional form, and that the flow in an aquifer that is homogeneous, saturated, and isotropic. So, yung mga equation, i-explain na lang ng next report. Thank you.
Radial flow from a well. Figure 4 show the radial flow from r equals to 0 at the well to r equals to infinity is the cone of depression radiates out from the well. For the theoretical analysis of the hydraulic head drawdown in a proposed well, we will make the following assumption. A single pumping well in the aquifer. Pumping rate is constant with time. Well diameter is infinitesimally small such that the volume of water removed from the well bore during pumping does not affect the total amount of water in the aquifer. Well penetrates the entire thickness of the aquifer and receive water by horizontal flow. Hydraulic head or initial water level is horizontal throughout the aquifer prior to pumping. Model the simple model because of boundary value problem as follow. Governing equation. Initial condition, boundary condition, drawdown at infinite distance from any time space. So, bali, explain ko na lang yung equation sa drawdown kasi yun lang naman yung mahalaga. Pakita ko na lang siya sa papel. Equation of equilibrium drawdown. This equation is galing siya sa Darcy Law sa unang reporter. Q equals to 2 pi r b times k dh over dr. Q equals to 2 pi r b times k equals siya sa t, bali dh over dr. Tapos equate natin siya sa dh equals to q over 2 pi t times dr over r. Take the integral in both sides. h1 to h2 dh equals to q over 2 pi t integral of r1 to r2 dr over r. h2 less h1 equals to q over 2 pi t ln r2 over r1. T equals to q over 2 pi times h2 less h1 ln r2 over r1. Yun lang.
Unconfined aquifer simply means an aquifer that does not have a confining layer between it and the ground surface. There are two types of flow in radial flow of unconfined aquifer. Number 1 is steady flow and number 2 is unsteady flow. To solve for the permeability of unconfined aquifer, gumagamit tayo ng Darcy's law, a law that describes the flow of fluid through a porous medium, where Q is equal to pi k multiplied by quantity of H sub 2 raised to 2 minus H sub 1 raised to 2 over ln R sub 2 over R sub 1.
Travel time of groundwater in confine. The time interval between recharge and discharge point is defined as travel time of groundwater flow. A local increase in the hydraulic conductivity of the sediment leads to a decrease in travel time. The higher hydraulic conductivity of the shell ridges yields shorter travel time. When the hydraulic conductivity is similar, there is a decrease in the travel time as the recharge increases. Travel time is used in several applications such as designing exploitation, monitoring system, identifying areas affected by contaminant migration, and assessing the potential for natural attenuation of pollutants.
Good day everyone, I am Cathielyn Bagasala and I am discussing to you the equations that govern the travel times of the groundwater flow into the circular and strip-shaped freshwater lenses which are the formula in this topic. First formula is the T is equals to porosity multiplied by the square root of 2 times P sub F, which is fresh water, plus the change of P over W, which stands for the recharge, multiplied by K, the hydraulic conductivity, multiplied by the change of P, and then again multiplied by the square root of R squared, less R squared, less the square root of R squared, less R squared sub I, less the ln of R, multiplied by the R, plus the square root of R squared, less R squared, multiplied by R sub I, over R, plus the square root of R squared, less R squared sub I, multiplied by R. R is the radial distances, and the, what is that again? Change of P is the difference between the densities of salt water. Okay, next formula, or the second formula, is that T is equals to N square root of P multiplied by the square root of P sub F plus the change of P over W multiplied by K multiplied by the change of P multiplied by the L squared less X squared less the square root of L squared less X squared sub I, less by the ln of R multiplied by L plus the square root of L squared less X squared multiplied by the X sub I, over L plus the square root of L squared less X squared sub I multiplied by X. So that's are the formula of the equations that govern the travel times of the groundwater flow. Next is the formulas or solutions for the sheets that discharge into tidal channels or freshwater bound lenses. Third formula is T is equals to N squared, N the square root of 2 over W times K multiplied by the square root of C squared less R squared less the square root of C squared less R squared sub I, and last the ln of C multiplied by C plus the square root of C squared less R squared multiplied by the R sub I, over the C plus the square root of C squared less R squared sub I multiplied by R. The fourth and the last formula is T is equals to N multiplied by the square root of 1 over W times K multiplied by the square root of C squared less X squared less the square root of C squared less X squared sub I, and then less again into the ln of C multiplied by C plus the square root of C squared plus X squared multiplied by X sub I, over C plus the square root of C squared less X squared sub I multiplied by X. That is the four formulas for this topic. Travel time serves a fundamental role in the relationship between the volume of the exploitation and the variation in the groundwater reserves, as well as in the possibilities of remediation in case of chemical degradation. So, guys, that's it. My discussion ends here, and thank you for listening to me. Thank you for watching this. I'm sorry for the inconvenience. Thank you.